So in this problem, we have to find domain and range and then sketch the graph of the given two functions. And both the functions are functions of two variables. So let us first solve the first problem. And the rule of the function is given by fxy equals to x squared plus y squared. And let it be equals to z. Now since we are dealing with calculus, so all the x, y, z variables, they will be real numbers. So what will be the domain of this function? Suppose D denotes the domain of the function. So domain will be the collection of all xy numbers in xy plane, is two-dimensional, such that when we plug in the values of xy in this relation, okay, this z will be well-defined real number. So what does it mean by z is a well-defined number? We should take x and y in such a manner so that it does not violate any fundamental rules of mathematics. For example, in mathematics 1 over 0 is not defined, right? So we should not take x values and y values in such a way so that z becomes something over 0. And what does mean by it should be a real number? Okay, now suppose there is a square root in the function. So square root of negative number is a complex number, okay? And we are looking for z as a real number. So we should ensure that these kind of situations should not take place. In this case, this x can take any positive, negative, zero real number, and same is the case with y. Okay, so in this case the domain will be collection of all xy in xy plane such that x can take any value in this interval minus infinity to infinity, and y can also take any value in this interval from minus infinity to infinity. So in fact this domain is the entire xy plane. Now what about the range of the function? Range of the function is collection of all z in the one-dimensional number line such that z takes values from this rule x square plus y square, where x and y are in this interval. So while thinking about the z values, that is the range of the function, we should also consider that x and y can take these values from these intervals. Now first thing is that z is equals to x square plus y squared, and we know that x squared will be always a non-negative number, y squared will be always a non-negative number, right? It means z will take values in the interval 0 to infinity. Z cannot take a negative real number values, firstly. Now the second question is the entire interval the range of the function? Let us go back to our rule. What is the minimum value of z for this interval? Okay, so z will be minimum when x square plus y square will be minimum. And when will be x square plus y square minimum? When x is equal to 0 and y equals to 0, right? So the minimum value of z will be 0. What about the maximum value? So the maximum value of x is tending towards infinity, and at the same time y is also tending towards infinity, right? So z value will also tends towards infinity. So yes, the range of the function will be this interval 0 from infinity, that includes the 0 number. So domain of this function is collection of all xy values where x and y values belong to these intervals, and the range is the interval 0 to infinity. So next we have to draw the graph of this function. Now what is the graph of a function? It's a collection of all x, y, z in space such that the xy points belongs to the domain, and domain is given over here, and z belongs to the range set. So one of the ways to sketch the graph is to plot all these x, y, z points in space. But this is easier to say than done. But in this case, the given function z equals to x square plus y square is the equation of a standard surface called paraboloid. Now any surface that can be written in this form, z over c equals to ax squared over a squared plus y squared over b squared, is the equation of paraboloid in standard form where a, b, c are constant. Now when a square does not equals to b square here, this is called elliptic paraboloid, and when a square equals to b square, this paraboloid is called circular paraboloid, because the equation on the right hand side becomes that of a circle. So ours is a circular paraboloid. Now how to plot this circular paraboloid? First we draw the three-dimensional coordinate axis system. So this is x-axis, I beg your pardon, this is y-axis, z-axis, and slightly tilted is x-axis. The screen of our digital device is in YZ plane. That's why this angle is perfectly 90 degree. Now let us have some drawing lessons. Now what is the plot of a parabola like y square equals to x? It is like the axis of the parabola is x-axis, right? So here we are having degree of x is 1, and that is the axis of the parabola. Similarly in 3 dimensions, because z is having degree 1, that's why its axis of the circular paraboloid will be z-axis. So it will open in upward direction towards positive z-axis. Now we are drawing this circular paraboloid. In YZ plane x equals to 0. So the equation will become z equals to y square, right? So this z equal to y square is a parabola opening in the direction of z. So we are first drawing this parabola z equal to y square in YZ plane. And we are taking this yellow color. So this is our parabola z equals to y square. Now another parabola will be in zx plane. This zx plane, in zx plane y is equal to 0. So this parabola will be z equals to x square, right? So again the axis will be z, it will lie in z xz axis. So this is xz plane. So we are plotting it xz plane, x second one, right? And now we are making these endpoints to meet. Perfect. This is x-axis, so we draw this x-axis. This one is y-axis, and you have recognized what? Well, it is in the shape of a tabla, right? With vertex at origin. Okay, it's going upwards, then this is a portion of paraboloid only. This is a portion of paraboloid only because it is an infinite extent in a z direction, and we can confirm it from here. X, y are taking all the real number system, so that's why x, y are taking all positive as well as negative value, but z is taking only non-negative integral values, right? That's why there is no portion of this paraboloid below this xy plane. No z negative values satisfies this equation. Again, this is the curve of intersection of this paraboloid by plane parallel to xy plane. Xy plane's equation is z equal to 0. So suppose there is some plane z equals to k. So this cut has been made by the plane, that's why we're getting it circle, and that's why it is called circular paraboloid. Had it been an ellipse, x square by 4 plus y square by 6, this shape would have been a ellipse, right? So this is the sketch of this circular paraboloid z equals to x square plus y square, and in multivariable calculus we'll be frequently using this surface.